Hello, everyone. My name is Joël Hébert. We're going to be doing a fun session today. So I always love doing sessions for the festive tech calendar, and I'd like to wish you all happy holidays. It's always great to seeing Bid in his toboggan or her toboggan, always rocking with that wonderful tree. If I look outside, a lot of snow here in Canada, and we're a little bit early in the morning, so we still got a lot of sunlight. I'm also feeling quite a bit festive. Got my hat on and a Montreal Canadian shirt just to get in the festive mood with you all. I'd like to talk to you today about something that's sometimes hidden. It's something called SNAT Port Exhaustion in Azure App Services. This problem can occur as well with some servers. It can happen with app services. Anytime you have a load balancer that it's basically translating addresses, doing SNATing, that can occur. Sometimes you can debug and have this issue and you won't even know. So I'd like to talk to you a little bit about the agenda today. So we're going to introduce some special guests. Santa and Mrs. Claus just going to drop by, and we'll be taking a look at some older articles. So I found two great articles for you guys to reference. One of them is ASP.NET Monsters, and the other one is I'll show you. It's called For Low. It's an excellent example of SNAT with examples, a walkthrough, great diagrams. So I just want to share those, community items with you. The reason I'm sharing the ASP.NET Monsters one is it was instrumental in helping me fix things maybe 5 years ago. So I just wanted to, give a shout out and then showcase it. After that, we'll replicate the issue that partner is possibly getting with sockets, and then we'll just have a fireside chat and draw out the partner SNAT Port Exhaustion in its simplest form. So this way, if you were in an elevator and you had to do an elevator pitch, 20 seconds, what is it? What do I have to look for? And something for you to retain next time you're debugging some issues. Definitely, we want to, hit that. So without further ado, Santa came by for a visit. I see he's got his gifts here. He's ready to go. Um, and told me that he has a website and the website is working well, except that one client says that they are having issues and can't send their order in, but everybody else is perfectly fine. So that's quite interesting. And what's that? Mrs. Claus has more information. Okay. So what is the extra information that you have? So you spoke with the client. Okay, and what was the main issue? They said something about sockets. So it sounds to me like this could be occurring on their side. That's why you're not seeing any of the errors. So maybe in this case, what we'll do is we'll try to go look in some of our instrumentation, see if we can determine anything, and we'll talk to the client and then take a peek, and maybe we'll just do some samples and take a look. Sounds good? Okay, let's go. So first and foremost, we know there's an issue. We know Santa has a website, and some clients are trying to fire call. So we're going to replicate. This client is unable to reach. They're calling Santa. It's an API-driven site. We're going to send some calls and see how come everybody is having success except this one client. Could be a multitude of things, but because they said they had a socket issue, that's kind of leading us into the right direction. So one thing we want to discuss. So first and foremost, let's just introduce today's topic there. So it's SNAT port exhaustion. And what exactly happens here? So when you have a workload behind a load balancer, it's going to use source network address translation in certain cases. And what happens is it allocates you a certain amount of ports to work with. Once you go over that limit, you don't have any more ports to work with. So if you are not closing your database connections or not using them correctly, you're not closing or utilizing HTTP clients correctly, you're quickly going to eat up all of your SNAT ports. So this also depends on how you're hosting, right? So if you're in app services and you're using the app service environment V2, V3, you'll have approximately 64 to 65,000 ports to utilize. If you're using the multi-tenanted, you probably have around 128 or maybe a little bit more, depending on scenarios. So you can run out pretty fast. So 400,000 clients coming to visit you at lunch and trying to do orders and whatnot, and you're reaching out to an API provider, not closing your connections or not reusing them, you're going to run out pretty fast, right? So if a backend instances used SNAT ports exceed its given SNAT ports, it will be unable to establish new outbound connections. So if a load balancer has 65,000 ports, it may only allocate you, 128. Other people are going to use the other ports. You use all your 128. You're not going to have access to the rest of those ports. Those are reserved for other instances. So once you exhaust those, then you're going to start having socket issues, and then that becomes problematic, right? So let's take a look at what this means. So if you take a look here in Microsoft's implementation area here, Azure Architecture Reference architectures, you'll see there's just the basic web app here. We have some samples. So I'm going to take this sample and sort of try to illustrate here. So we have a multi-tenanted web app here. So what happens if you have your app service plan and you have there's your web app. So this web app basically goes and tries to fire a call, and we're just going to write underneath it. This could be just an API. And from this app, we go outbounds and we call this API here. What's going to happen? We're going to have to establish, a socket. We're going to need to have a connection. And basically, we go ahead and call this API. We get data. This here, when you take a look at, basic TCP, it's going to do, it's going to do the handshake. It's going to do establish a connection, but then it's going to probably hit what's called a time wait, and then it's going to wait 4 minutes till it closes the connection. What it's waiting for you to do is to reuse that connection, right? And then refire, and then have a very clean channel. You'll see examples when I go to the ASP.NET Monsters page, where we'll look at TCP view and what's a clean rendition and what's something that is leaking connections. What you don't want is this, for every time you're going to call that API, you're establishing a new connection. There is a load balancer here, right? So that load balancer there is the one doing the source address, source network address translation. And what it does is this can have multiple addresses inside of the stamp. It's just basically going to act as, like a perimeter between external parties and you, and sort of masquerade your internal IP addresses, right? And I'll explain that a little bit in the next article of how that works. But what you don't want is, anytime you do an external call, it goes through that load balancer. You have a limited amount of connections available. So if you go ahead and fire 1,000 calls with leaky connections, and you have 400,000 clients coming in during a lunch hour, you can see how you can exhaust those ports really fast. Multiple ways of detecting these things. And like I said, this is the multi-tenanted one. If you're using the app service environment, obviously that load balancer is yours. And if you take a look here in the documentation, it clearly explains that, right, you have 64,000 ports eligible for SNAT. But if you are sharing that load balancer with a multitude of clients, you will be limited with the number that you have. So if you're using the multi-tenanted app services, you'll have approximately about like 128 or whatnot. If you're using the app service environment, you'll start off probably with something closer to 64,000, a lot more leadway. And then we'll talk a little bit later about using a NAT gateway, where you can assign multiple IP addresses and have quite a few ports. It's very good for immediate remediation if sometimes you don't have access to fix that leaky connection or whatnot, right? So the other thing that's very important, it's not only about HTTP connections. You see here the app service plan here is connecting to a database. Those take up connections as well. If you are leaking those type of connections, that's not good. So you want to rectify that as well. So you have to take a look at doing effective reuse. So when you're in Entity Framework, you're going to look at DB context. When you're doing HTTP calls, your HTTP client, you want to make sure that you're doing effective reuse. And when you're doing database connections, you're not just using one per instance and not reusing anything. Different techniques for different scenarios, but today's scenario, we know we're offering an API, so it seems like the client is doing excessive calls and then getting some kind of a socket exception. So we'll take a look at that. So let's just talk a little bit before we look at a demo of what is the issue. I very much like this article from Forlow the Rabbit. .github.io, and they have an excellent delay and execution test that you can have. It seems to be open source, and you can test it out there. So what occurs is, so Azure App Services, for example, you have your stamp, you have different worker instances. You see here there's a single IP, a couple of different sites here with the web application. As the traffic goes through the load balancer and an external endpoint, right? you know it goes through this single element here, this load balancer, right? So traffic that gets initiated where? From here, that needs to go outside, right? And leave the instance, and it goes to, you know, the external endpoint, goes to the load balancer, and then, you know, it's created from this address. So this is your from address, your to address, this is your intermediary. And you'll actually see how, you know, SNAT is working here. So we saw three different addresses, right? So you see it here very clearly. So you have your source address here. So I'm coming from .60. I want to go to 180. So that goes through your load balancer. The load balancer is at 72. So this package here sees 72 as the inbound, and it is, you know, 180, which is its own address. On the way back, now you'll see the implication. So now the source address is the address of the partner or the API or whatever we were trying to get to. And it's actually sending where? It's not sending back to .60, right? Sending back to the load balancer, which is 72. And then this is going to do that translation and say, okay, I've got a packet, you know, package, I should say, coming from 180. I'm going to resolve it. It's going to go to 260 where it's supposed to go. So you can see here that it's masquerading the internal IP addresses, right? So you don't have to expose, you know, 400 internal IP addresses. You have that single load balancer as the, you know, the element guiding you in and out. Um, so that's that. So what we know is that we have, right, a limited amount of these, right? So if I take all of this as a whole, there's a limit on how many, you know, translations I can do, right? So you saw there was per IP about 64,000 if you, you know, own that and manage that load balancer and in different scenarios. But on a regular multi-tenanted web app, you're probably at 128. So if you start leaking connections, you'll find out very quickly. You're going to have basically SNAT port exhaustion and socket exceptions everywhere. So that's where you have to, you know, manage and make sure that everything is fine. So let's take a look at what is the implication for one of these leaky connections. So as I promised, the article that I like is from ASP.NET Monsters. And like I said, this is you know, a dated article, but it's absolutely fantastic. So when this came out, I kind of read the article because I love following this blog. It's fantastic. And they were saying that you're using HTTP client wrong. It's destabilizing your software. And I was like, well, wait a second. I think I'm a pretty good practitioner. I should be using HTTP client correctly. And actually, I was doing this error kind of back in the day. And this is, you know, back in 2016, not everyone was in the cloud. A lot of on-prem servers. They work a lot different. Whether you're calling, you know, if you're calling an HTTP client and you're firing something internally and it's not going through a load balancer, the time wait might be not instantaneous, but it can take time with the TCP stack depending on how it's configured. But usually, I think the Azure load balancer is approximately like 4 minutes is the time wait, so you can hold on to a connection for quite a bit of time. But you see here, it's doing the, you know, the regular using with HTTP client. So you're thinking it's going to dispose, but you still have that time wait that takes, you know, approximately 4 minutes. So I went up and cleaned up my code with their recommendation. So this was a, you know, a leaky HTTP client implementation. You can kind of see it here where they talk about, you know, they do a quick for loop and then it establishes 10 connections, and just have a small demo just so you can see a visual. So here I've got TCP view. So TCP views from sysinternals allow you to, you know, monitor the TCP connections on your machine. You can alternatively, if you don't feel like downloading that element, go ahead and do a net stat, and then you'll get all of the addresses as well. It's just not as fancy. There's other things you can utilize. So basically, if I take this view here and I, you know, I'll fire up my implementation. See here, it's doing a bunch of connections, and then it's a, you see here I'm establishing, and I've got a whole bunch of these time waits here that'll get created, right? So let's do this a couple of times. 1 second. Here we go. Some more, and then we'll wait. So you see them getting established, and then here they're closing, and away you go, right? So if I take another example here, let's just see. Just fire a few more executions. Okay, so you see them, they're green, and then they go to established, time wait goes off. So if you have a load balancer, that might take a while, right? So you see I do have some time waits here, but you saw how many connections got created. That's what we're going for here, right? So in the green, the load balancer will hold on to those for approximately that, like 4 minutes, and then it'll release it, right? So it'll get stuck in that limbo state that says time wait, right? So if there is, a different technique here where you're, reutilizing that HTTP connection, that goes in, can come in and save the day. So if I basically, change my implementation to not use an HTTP client like this, and then I want to use, go up here, second, just a comment there. So let's say that I, opt for this technique. Let's see how much green we see now. So I just boom one, that's it. It went real fast. And I don't see, the other one had like 10 implementations. So it's cycling. It just reused the connection. So let's stop this. Fire. And you see how small the screen is. I'm not getting a lot of activity. And that's it. So if you do go peruse that article, you'll see that it does talk about the TCP flow. So if you're interested in that, it'll teach you a little bit about, the listen state, when a connection is established, right? When it's in time wait here, and then there's going to be essentially a timeout, which will bring you to a next state at a certain point. So when they talk about the fixes in here, they have a HTTP client that's reusable. So this way you don't go ahead and then it burn through all of these sockets, right? So I don't think this article necessarily talked about SNAT port exhaustion, but it is remediation for one of the things that we do see with port exhaustions here. So you can see here how many, if on their server they saw like waiting here, and then you see once they do the resolve how much smaller it is. So give you some recommendations. There's a lot of other things online, but I really like this simplistic article. It explains it really nicely, and it's a great introduction into TCP for those who don't delve into it. And the two main things is you now have access to a little test area, of a tool. So when you are working locally and you are, doing heavy API integration, firing to 10, 15 different APIs calls, you can actually monitor here for your time waits. And based on that, you can basically see if you have leaky connections or not. You'll see a whole bunch of them will be in your time wait limbo. Okay, so this said, the next thing we want to do is we want to take a look at that implementation. So I just want to talk a little bit about, the test area that we have. Test here. So if I, just zoom in, I have a small project, S Nat example. So I have a Santa's fulfillment site. So what we'll do here is, we'll just pretend it's doing, a small unit of work here. So I'll just put, 30 seconds of work. Quite long for a website. So we'll give it 3 seconds of work. And I'll just redeploy. I didn't want to do 60 seconds because we're doing the demo. And certainly we don't want to wait 60 seconds for 10 executions. It would be 10 minutes. So what we'll do is we'll just publish this. So we'll send that out, do just a small unit of work. And then we have an API here, client unable to reach API, and that's the one we're going to be taking a look at. So for this one, there's a fulfillment controller. In this fulfillment controller, we have an issue, right? We have a leaky connection, and we're sort of mimicking that partner firing to Santa's fulfillment site. And what's going on is they're not reusing the client. They're exhausting their HTTP clients. They're hosting an app services, so that they won't have that many. We won't have 64,000. They're not using an ASC. They're just using the public multi-tenant. So let's take a quick look at that. So if I go here, here's Santa's fulfillment page, and here's the the partner trying to do those calls. So if I go ahead and wake up many instances, and they're cycling, they're going to send quite a few thousand. You can see I was running this earlier, and we're already getting SNAT port exhaustion. So I'm just going to open up a few instances. You can ultimately use load test software if you want, like Load Runner or anything based off of JMeter works as well, or anything. I'm just doing these, and these are cycling quite a few hits to the site and opening up connections. So the thing that we want to do is we're now just going to take a peek, right? So I'm not going to wait for App Insights to collect all the data and all the hits. It'll take way too long for the length of this session. But what's important is basically on the client side, you're going to be seeing some red, right? So the red is always associated to issues. So in Application Insights, we're going to go to our failure area, and we're going to want to take a look at what's going on here. So if I take a look, I do this for the last 7 days, and you'll see here there's a 500 and some socket exceptions. Let's drill down into some of these. So let's get this one here. So you'll see that there's a socket exception occurring. So if you do see socket exceptions, you probably run out of sockets, or utilizing them in a way that's not permissible on that server. And if you do take a look at, show me what happened before and after the request of this user flow. Let's go into, let's see if I can zoom in. Perfect. So yeah, so operation starts, the initial event, right? We're calling the fulfillment get. The get knows it has to do an operation, starts to do a some kind of a get statement, and tries to get the elements, and then right here there's a socket exception, and that blows up. So we know we're actually getting into our I guess we'll call it our API client, and then the API client is trying to reach our site, and then we're getting that that socket exception. Nothing complicated here, but we know that we're exhausting those items. So one thing that's important to note, and I'm just going to go here, is that if you go to the actual client itself, there's things to help you. You see diagnose and solve problems. So if you go to diagnose and solve problems, and we do SNAT, you'll notice that there's two elements, right? One of them is, right, it's under availability and performance. It's SNAT Port Exhaustion. The other one is SNAT Field Connection Endpoints, right? So when you start looking at these, it'll tell you a couple of things. What's going wrong with your initial API that you're looking at, and it also hint at other things that's going on. So it's looking at data, but it's also going to mine data for everything inside of your subscription as well. And if I have a quick example here, so what we'll do is take a quick peek. So here we have that socket exception, right, on our unable to reach API, the one from the Santa's client. And then we want to dig into one of these two, right? So the first one we'll look at is SNAT Port Exhaustion, and it will tell you that it has pending SNAT connections that are detected. And it also is going to tell you on which instance it's been detected here. So here's the machine name. So it says essentially like out of one instances, is here. And then it's going to give you your SNAT port usage here. So notice like 160, it's way above here. And then we're trying to allocate SNAT ports, and no, that's it. They're out. If you go to the SNAT failed connection endpoints, it's going to show you failed SNAT connections are detected, expand for different solutions. This is just going to give you some tips on what you can do. Number one is actually fixing what's leaky. Definitely fixing, like I showed you with the HTTP client, reusing database connections, efficient use of DB context. Things like that is probably the first thing you should do. After that, there's other things, and we'll talk about those in a second. The next element is probable endpoints contributing to SNAT. So this is smart enough to know that you are trying to call Santa's fulfillment website on this outbound endpoint, and that's having some serious issues. So it knows that you're trying to do HTTP calls over to this partner here, right? So remember when we had those tuples, we had who's trying to call who and going through the load balancer. This is smart enough to know that you are having SNAT issues. When you had those SNAT issues, you're trying to establish connections to where? To this Santa's fulfillment site on this address. And then there's an aggregate timeline of where your failures are. So here you'll see like here there's different amounts. So here there was 2 of them. Here there's 20, 30 or something, and it's an hourly aggregate of how many failures you're seeing, right? So we know that the root cause of this is not closing connections, not having the right topology. We know that we can see the issues in application insights. We know that we can use from the the diagnostics and diagnostics area inside of web apps or API apps. we can use this SNAT field connection, endpoints, and SNAT port exhaustion just to sort of see what's going on and to take a look. There is one interesting thing, I believe, and there's an area where you could click. Let's see if I can. Was it here? It said it would actually take a look at your whole instance. So this is still aggregating data, and we're kind of waiting for some to come in. But you see here, scan subscription and find the complete list. It's going to scan the subscription and find the complete list of everything. So right now it's not finding the issues. It takes about 3 to 5 minutes for everything to show up in application insights, get aggregated for you to see. It's not like instant. But the time range is also 24 hours. So the last time I did this demo in preparation for today was yesterday, and definitely we can all see the failures. Those I showed them to you in the other instance, right? So without further ado, one way to to fix SNAT port exhaustion when you're using multi-region VNet, right? So you know that with this instance, it's possible that you're limited to, right? We said approximately 128 SNAT ports. It can be higher, but we'll use that as a baseline just for tutorial purposes. You can do the VNet integration and put it inside of a virtual network and then utilize the NAT gateway. At that point, you for every IP that you're going to assign out of that NAT, you're going to have 64,000 approximately addresses to utilize. So if you need a quick fix, you're not going to open up the code or anything, put it through and then utilize the NAT gateway. That's a quick fix. But definitely going inside, your building blocks here and then fixing any issues, that's definitely something to ponder on. There's also an interesting case where you can have databases and you're exhausting a lot of database connections going through the public channel. Definitely you can use service endpoints and then use this route instead of going through the public route. Different techniques, and those are outlined in many different articles. And one here that's very interesting is sometimes you will get some of these database issues. If it's a socket issue trying to connect to the database, I would take a look at SNAT port exhaustion. But there's also important things like for you to look at the connection pool setting, right? If you have it to a really low number, that can cause issues. I've seen web apps run at 99%, 100%, that you're going to have issues with pre-login. This occurs sometimes when you get a really big spike in traffic. You're not on the right SKU or the right stamp, for the type of traffic you're having. The web app CPU, gets pegged at like 99, 100%, and at that point it can't do the handshake, right? And then you'll have some problematics. So once again, I just wanted to do a quick recap here. Let's go to my site again. So I want to go back to here. Perfect. So we've seen that if you clean up your HTTP connections and are reusing them, you're going to have the traffic going back on that immediate channel. If you don't, you're going to get SNAT port exhaustion. What you're going to do is you're going to have a whole bunch of calls going back and forth and holding on to those connections, and they will be stuck. And what happens to them, right? You're going to see them as time waits. So one good way is to use a tool called TCP View when you're debugging locally and initially, developing that initial API call out. You'll be able to see if you have a whole bunch of those time waits. That's definitely going to lead to SNAT port exhaustion. So that's something that you want to fix. Otherwise, yeah, so fix that up and then move it across. Here it's a fully multi-tenanted solution here, this basic web app. If you don't have time to open up this code and fix something, and you don't think you're going to exhaust 64,000, there's always that opportunity, right, to do that VNet integration with that app service and place it in here, and then utilize a NAT gateway, and then that's going to then call your app service. And then here, if you're exhausting a couple of 100, 200, and that's not going to fail because you now have access to 64,000 times the amount of IP addresses you you allocate. So this could be a unique scenario because sometimes you don't have access to all of the source code, right? You have access to your source code. But what happens if you're utilizing a package and that's the package that's causing the leaky connections, right? So that package is a third party. You put in a request with the open source provider to fix it. It might take a week or two. Well, then at that point, you're stuck. You can't open up the code. If you want a quick remediation, you have one here, right? So just you know, a quick chat there on that one. You're having poor socket issues anyways. So you have two options. It's either to find another provider, get rid of that one, call the API yourself, or utilize some different package, or at times sometimes rolling back a package is is something that you can do. So on that, I just want to thank you for spending time with me and Bit today. Always like doing the festive tech calendar, and I hope that this whirlwind tour of Azure App Services and SNAT Port Exhaustion has been helpful. So if you do see a socket exception one day, I hope you think of me and do go peruse the two providers that I showed you. So the ASP.NET Monsters, and I always forget the other website because it's complex. It's called Follow the Rabbit, which kind of like follow the rabbit.github.io. Fantastic content, very much like the explanation, and they have these, SNAP port exhaustion calculations. They talk to you a little bit about, 128 ports per instance. When it gets exhausted, you see here, it's kind of similar to what I showed you in App Insights. You'll see a socket exception, but the best part is they have ready to go a lab that has a website that's delayed and one that has a source network address translation for you to take a peek at. So on that, thank you very much. It has been very fun chatting with you in this festive tech calendar. And on that, I'd like to wish you happy holidays. Thank you.